Hello everyone. I'm here to present on dissolution enhancement of aceclofenac using co-precipitation method. Aceclofenac is an NSA drug that is used to relieve pain and inflammation. It is a BCS class 2 drug which has poor aqueous solubility. Introduction. One of the most challenging aspects of drug development is to enhance oral bioavailability of poorly water-soluble drugs. There are several techniques for enhancing solubility, which includes physical modification by reduction in size, modification of crystal habit like polymorphism, amorphism, co-crystallization, etc., and drug dispersion carriers like solid dispersion. The chemical modification can be done by change in pH, salt formation, complexation, etc. And the other techniques, which includes use of adjuvants like hydrotropy, co-solvency, and surfactants. Objectives. The main objective was to enhance the dissolution of aceclofenac by co-precipitation method, which in turn increases the bioavailability of the drug, and also to select the best excipient that is suitable for dissolution enhancement of aceclofenac. Coming to methodology, we have used co-precipitation method for enhancing the solubility of aceclofenac. In this method, the drug was mixed with powdered excipients in a molten basil and it was transferred to a china dish. To this, acetone was added and it was subjected to a temperature of 40 to 45 degrees and heated in water bath with constant stirring. By this, the acetone gets evaporated and the resultant was stored in a glass desiccator at room temperature for 24 hours. And the final product was then dried and crushed into particles and passed through sieve number 60. These are the different ratios of drug excipients we have used in co-precipitation method. The different excipients that we have used are aerosol, urea, and PVP-K30. The amount of drug and excipients that are used in the ratios of 4:1.5 and the amount of solvent used is 15 ml. A selection of best excipient for dissolution enhancement. This was performed on the basis of percentage yield, drug content, and drug release in phosphate buffer of pH 6.8 within 60 minutes. Evaluation. These are the sum of evaluation parameters that we have performed. Percentage yield. The percentage yield was performed by weighing the co-grinded physical mixture and calculated as a ratio of actual weight of co-grinded particles obtained to the total weight of drug and polymers into 100. The drug content was determined by using UV spectrophotometer at 274 nanometer. Angle of repose. The angle of repose was performed to know the flow properties of granules and was obtained and was determined using funnel method. Formulation development. 100 mg of equivalent aceclofenac granules were filled in 0 size hard gelatin capsule by hand filling method. Uniformity of weight of capsules. It was performed according to USP procedure, and in this method 20 capsules were taken and their weight was determined individually, and the capsules were emptied and their empty weight was determined. To calculate the net weight of powder, the difference between the weight of filled capsules and the weight of empty capsules were performed, and which gives their weight variation. And finally, in vitro dissolution studies. The in vitro dissolution studies were performed using USP type 1 apparatus, that is basket type. And the steering speed maintained is 100 rpm. Temperature maintained is 37 plus or minus 0.5 degrees Celsius. The medium we have used is 900 ml of phosphate buffer solution of pH 6.8. This study was carried out for 1 hour and at predetermined time intervals, 1 ml of liquid was withdrawn, it was filtered and assayed spectrophotometrically at lambda max of 274 nanometers. And at the same time, the fresh medium, which was pre-warmed at 37 degrees, was replaced into dissolution medium to maintain the sink conditions throughout the study. A factorial design was performed and a total of 9 formulations were prepared using drug and 3 different polymers. Each of 3 experiments were done for 1 polymer, and with three different independent variables which are coded as -1, 0, and +1. In this, the -1 indicates low level, 0 indicates medium, and +1 indicates high levels. In this, the amount of solvent is denoted as X2 and the amount of polymer is denoted as X1. These are the coming to results. These are the evaluation methods of different formulations. And in this, the batches B1 to B3 are prepared by using excipient aerosol, and batches B4 to B6 they are prepared using urea, and from batches B7 to B9 they have prepared using PVPK30. The percentage yield of all the formulations was in the range of 92 to 98%, and the highest yield was found to be batch B2 with 98.18%. And the drug content was in the range of 97 to 105, and the best was batch B1 with 105.07%. The angle of repose for all the formulations was found to be excellent, and the batch B2 showed least angle, that is 16.16. The average weight of capsules was in the range of 216 to 242. Coming to the drug release studies of 9 formulations at different time intervals, which are performed in triplicates, are as shown in this figure, as shown in this table. The batch B1 showed the better drug release compared to all other 8 formulations, with drug release of 75.32 after 60 minutes. This graph depicts the percentage cumulative release of co-precipitation of all 9 batches, in which the batch B1 gives the highest drug release at 75.32. The in vitro dissolution studies of batches suggest that the batch B1 that is prepared using 4:1.5 drug and aerosol and 15 ml of acetone as the maximum release of drug, and this is because of more amount of hydroxyl groups were present on the microparticle surface of aerosol, which absorbs water. This dissolution ability is maybe due to greater specific area, and the amount of aerosol increase. And the further increase in the aerosol, that is from 4:1.5 to 4:2, as shown in batch B3, there is a decrease in the release of drug. And also in the amount of acetone, that is by increasing the amount of acetone from 15 ml to 25 ml, as in batch B2, that with 25 ml, there is a decrease in the drug release because the drug was more dispersed when more solvent was there, and hence the reduction of size was more, in which this may be due to increase in micronization. Selection of optimized batch. The optimized batch was selected on the basis of all evaluation parameters, and from all the 9 formulations, batch B1 is selected as optimized batch. Then the final formulations prepared according to procedure as described, and the percentage release and drug content of the optimized formulation was performed. And it is compared with that of pure drug, which are shown in the table. This table shows the percentage cumulative release of co-precipitation prepared drug and percentage cumulative release of pure drug, in which the drug prepared from co-precipitation shows highest drug release after 60 minutes, that is 77.41, whereas the pure drug shows 32.86 only. This graph gives the percentage cumulative release of optimized batch and pure drug release, in which the optimized batch using co-precipitation method shows highest drug release than pure drug. Finally, coming to the conclusion, on all the basis of evaluations of all 9 formulations, batch B1 is considered as the optimized formulation, and this batch B1 is compared to the percentage cumulative of pure drug, which is also higher when compared to this pure drug. Thus, the formulation B1 enhances the dissolution of Aceclofenac by co-precipitation method, which in turn increases the bioavailability of the drug. Thank you.